Hello everyone. We are now going to begin our lectures on chapter 4, which will take us into the history of the number systems. So we are going to look into how some of the ancient civilizations came up with their number systems, their numerals, their ways of counting and representing numbers, and also see how we can translate their numerals to our number system that as we know today, right? So we are going to spend time understanding the Egyptian system as well as the Roman numeral system. We're going to first understand the difference between numbers and numerals, and then we are going to go into some of the ancient numbering systems which use the additive system. As the word additive suggests, there's addition involved in it, and with addition comes subtraction too. So we will learn about essentially the Egyptian system and the Roman systems, both of which use the additive system of numeration. Now, before we go into studying the different systems of numerations that have been in existence from ancient civilization, ancient times, we need to understand the difference between these two terms here, a number versus a numeral. Now, many times in loose conversation, we often use these terms interchangeably, but there is technically a difference between the word number and the word numeral. A number represents a quantity. It is a quantity. It is something that comes from counting different things or items or people or whatever it may be. So it answers the question, how many? That's what a number is essentially. It's a quantity. A numeral, on the other hand, is a symbol to represent a particular quantity or a particular number. And different numeration systems use different symbols. However, the symbols that we use, or pretty much is used all over the world nowadays, is called the Hindu-Arabic numeral system. All right, Hindu-Arabic numeral system. This system was or originated in ancient India thousands of years back, and then the Arabs, as they came in contact with the Indians, they they adopted the Hindu system. They used to interact for purposes of trade and other through other interactions. It became known as the Hindu-Arabic numeration system. All right. So it is a very useful system because the Hindu numeration system had a symbol to represent 0. And we will shortly learn the importance, the value of that particular numeral, which is a 0. Right? Now, in the Hindu-Arabic numeration system, the numerals that we use, and we are all familiar with that, otherwise we wouldn't have come up to this stage of our study of mathematics. It starts from 0, and there are 9 other numerals, so 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, so altogether, including 0, there are 10 different numerals, and these numerals represent certain quantity, different quantities, or in other words, different numbers. So 1 represents just one item, correct? The number 1. This symbol 2, written like this over here, this symbol, let me take out my pointer here. This symbol 2 represents 2 of a certain item. 3 represents, and I'm just using vertical lines, but it could be any item, anything, any people, anything. And then 4 represents 4 items. 5 represents we would have to draw 5 lines, vertical lines, and we could keep going like this. So 9 would, to represent 9, we would need 9 vertical lines. However, it's very cumbersome to and it's not practical enough to represent numbers by drawing lines, correct? How do we how would we represent a very large number? For example, 99. Would we draw 99 vertical lines like this, right? It wouldn't work. It would make things very difficult. So instead, we came up, or the system, the Hindu-Arabic numeration system, or any system for that matter, they came up with numerals or symbols to represent these quantities here. Now, in the Hindu-Arabic system, like I said, we start with 0, and 0 represents something when there's nothing to count really. All right, 0 by itself represents when there is nothing, a number which when there is nothing to count. All right. However, 0 becomes very useful when it appears to the right of any of these numerals, right? It is useful to represent higher or larger numbers, in fact very, very large numbers. 1,000,000, 1,000,000,000, they all have bunch of zeros to the right of a certain numeral, non-zero numeral. All right, so that is the importance of 0, and therefore the Hindu-Arabic system, which came up with a way of representing 0. And all the other numbers higher than 9 are represented using a combination of these 10 numerals, correct? So if we want to represent 68, we would write 6 and an 8 next to it. So 68 is created using 2 of these numerals that are in existence in the Hindu-Arabic form. All right, so that's about the Hindu-Arabic system that I briefly introduced here. We'll talk in greater details about the Hindu-Arabic system later on, but essentially this particular slide was to explain the difference between the term number and a numeral. So keep in mind the numeral represents a symbol, and different enumeration system. We learn about the Egyptian system, the Roman system. They had their own symbols to represent different quantities, different values. A number, on the other hand, is a quantity. All right, it answers the question how many. A numeral, on the other hand, is a symbol to represent a quantity. Okay. So I think we pretty much now understand what a system of numeration means. So let's just read through it. It says a system of numeration consists of a set of numerals and a scheme or rule for combining the numerals to represent numbers. So we have our numerals, for example, from 0, 1, 2, 3, 4, and so on, all the way to 9, but we also will learn how to come up with a rule, special techniques to combine the numerals to represent different numbers. So to represent the number, let's say 48, we write it like this, right? But there is a rule that we must follow to come up with the numbers higher than 10. Oh, sorry, higher than 9. All right, so that's the system of numbers or number system. It consists of numerals as well as the underlying rule by which we combine the numerals to represent different numbers. Now, there are 4 types of numeration systems that we will learn of. The first one is the additive or the repetitive rule. As the name suggests, the additive rule means we use addition in some form to come up with a number from the numerals. All right, and then we have what's called the uh, multiplicative rule, which involves multiplication. Then we have a ciphered system, and finally we have the place value system. So we will spend time and we will talk about some of the ancient systems which applied or which used these rules, and we'll also work on how we calculate the numbers from the numerals or from the pattern of the numerals using these different systems. Now we'll first start with the additive system. An additive system is one in which the number represented by a set of numerals is simply the sum of the values of the numerals. All right, so I can understand just reading the definition won't mean much, but we'll go through specific examples and see how the additive system works. But what this definition tells us is we will be given a pattern, numerals arranged as a set pattern, and the way we come up with the number that those numerals represent is through a system of addition, the sum of the values. So to use a simple example here, this let's just have these numerals here from our system 2, 3, 5. Now we would think, or we know that 2, 3, 5 when placed together in this pattern represents 235, but we don't follow the additive system. We follow a different system called the place value system. In the additive system, what this would be is to add the quantities each of these numerals represent. So in the additive system, this 2, 3, 5 arranged this way would mean 2 plus 3, all right, additive, so we have to add the numbers. It says sum of the values, so 2 plus 3 plus 5, which is equal to 10. So 2, 3, 5 in the additive system would represent the number 10. It wouldn't represent the 235 as we know it. All right. So we will go deeper into the additive system through some of the ancient methods that we will soon learn, the Egyptian method as well as the Roman method. All right. So the additive system is one of the oldest and most primitive types of systems, and the examples of that are the Egyptian hieroglyphics and the Roman numerals. All right, so we will work through some examples using the Egyptian hieroglyphics and the Roman numerals. So first, let's look at the Egyptian numerals and how they are represented. Now, in the Hindu-Arabic numeral system, our numerals start from 0 and go all the way to 9, correct? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we start repeating them to represent higher values. In the Egyptian system, there are 7 numerals, all right? And just like in our system, our numerals increase by 1. So from 0 and then 1 more is represented by 1, then 2 is 1 more than 1, and so on. In the Egyptian system, the numerals increase by tens. So this staff here, it's called a star, but it's really a vertical line. This vertical line represents 1. And then this downturned U, it represents the number 10 as we know in our system. Then this this figure here, which looks like a curly 9, or so to speak, a curved 9, represents 100. Then we have this figure, it's called the lotus flower, but to me it doesn't quite look like a flower. It looks like some gift bag perhaps, but anyway, it represents the number 1000. So you see the numbers are increasing by tens. Then we have something, it's called a pointing finger, and that's 10,000. Then tadpole, which looks like a fish, is 100,000, and then an astonished person, okay, that represents 1 million. All right, so as you see, it keeps increasing in not by one number at a time, but by tens. All right, so now we will learn when these numerals are arranged in a pattern, what numbers they represent. So we are going to learn a technique, a pattern to interpret these arrangement of numerals and what numbers they represent. So we are given an example here. We see a pattern of these Egyptian numerals and it represents a certain number. So we are going to convert this pattern using the additive system and figure out what number this represents in our Hindu Arabic system. All right. So what we see here are, first of all, from the left side. So let's move from the right to the left side. All right. So we see 4 straight lines which represent staff or vertical strokes. Then we have a downturned U which represents the heel bone, and that corresponds to the number 10 in the Hindu Arabic numeral system. And then there are 3 ropes, coiled ropes, so to speak. It says it's a scroll, and that each of these represent the number 100 in our system. And then finally we have what's called a pointed finger in the description of this numeral, and that represents the number, what is it, 10,000, right? So the way we are going to convert this, now again keep in mind this is the additive system, so there's addition involved. So all we are going to do is replace each of these hieroglyphic figures with the corresponding Hindu Arabic numbers or numerals, and then we are going to add them up. All right, so let's try to do that here. We have what is this? The pointed finger represents the number 10,000, right? So I'm going to put here 10,000, and we have 3 of them, so we got 1 so far. So 10,000 plus 10,000 plus 10,000. All right, and then we have 3 100s, correct? The scroll represents 100, so it's going to be plus 100 plus 100 plus 100 for each of these scrolls. And then we have a downturned U which represents it's called the heel bone, I guess, an arch, and that represents 10. And then we have 4 1s, so since they don't have a particular numeral to a specific numeral to represent 4, so we have to use this 1 here. So 1 plus 1 plus 1 plus 1. All right, and now we are going to add them up. So we have 10,000, 10,000, 10,000, 3 10,000s, 30,000, and then 300. So let's do it this way: 30,000, and then 300s, and then 10, right? 10 and 4, right? So when you add up all these values, you should get 30,314. So let's see what the solution is that they've given us here. All right, so the solution has done the same thing. It has 10,000 that matches with our answer, 10,000, 10,000, 10,000. So just plug in the values of each of these numerals and then add them up. That's exactly what they have done, and for an answer of 30,314. So this is how we are going to go about converting from an Egyptian system to the Hindu Arabic number system. All right, so now we will try to see how we can convert from the Hindu-Arabic numeral system to the Egyptian system. Now here we are going to learn how to convert from the Hindu-Arabic numerals to the Egyptian numerals. All right. So now we are going to reverse the steps that we had done for the previous example. Here we are given the value in Hindu-Arabic numerals. We will first read this numeral, read this value, and then we will write it in additive form, and then we will plug in the relevant Egyptian numerals to come up with the numeral. Now this is going to be the end result here at the bottom, but we will see whether we come up with the same numeral as they have come up with. All right. So the first step is to recognize that this is a number which is in millions. All right. So it has 6 digits after the 1, so that makes it 1 million, right? So that matches here, 1 million. So 1,203,462. 1,203,462. That's what this number represents. So we are going to break this up and rewrite this in additive form. So start with the 1 million. All right. So it's going to be 1, and there are 6 zeros in 1 million. So 1 million, and then what do we have here? 203,000. So for now I'm going to write it as 200,000. All right. So 200,000. And then we have 3,462. So I'm going to first write the 3,000. So plus 3,000 plus 400, right? This is 400. So 400 plus 60 plus 2. All right, plus 2. So now all this is in Hindu Arabic numerals. All right. Now we cannot just plug in the Egyptian numerals just like this, because there's no single numeral that represents 200,000 as a whole, right? So I have 1 0 missing here. This should be 200,000. And then we don't have a single numeral to represent 3,000. So we have to break this up further. 200,000. We have a numeral for 100,000. So we will have to break up 200,000 into 200,000s. All right. Now you can use the multiplicative here, but let's write this. So 1 million is fine. All right. 1 million. And then I'm going to just use a little bit of shortcut here. So 2 times 100,000. So that will tell us that there are 2 100,000s rather. All right. And then plus 3 1,000s. There are 3 1,000s. And then there are 4 100s. All right. Plus 6 10s. 6 10s. Plus 2 1s, correct? And now we can go and plug in the Egyptian numerals based on how many of each numeral will go in to the pattern will be determined by these numbers here, 2, 3, 4, 6, 2, and so on. All right, so there's 1 million. So what is the symbol for 1 million? It's this astonished person or something. So I'm going to write that. All right, the astonished person. Then we have 200,000. What is the symbol for 100,000? We need 2 of those. So this tadpole or fish like figure here. So it's going to be something like this. And we need 2 of these, right? So we'll put 2 of these. All right. And then we are done with this. Let's use another color here too. So we are done with this. We are done with this. We need three 1000s. What's the symbol for 1000? This lotus flower. So let's see if we can draw those three lotus flowers. We need three of those. So that's kind of like over here. Hold on 1 second. We have this. We'll use the same color. And something like this. We need three of these. So we got our 3000s and then 400s. What's the symbol for 400s? This looks like this here, here. We need four of these coils. And then what do we need? We need six of the 10. So six of the downturned U's, the arches. So 1, 2, 3, 4, 5, 6, and then two ones, which are two straight lines. All right, so let's see if that matches with what they got here. And I'm going to just redraw this because this writing has come over. So we have the astonished man. We need two tadpoles. All right, we need two tadpoles. And we are good. So let's see if it matches with the solution. So yeah, we got an astonished man. Then we got two tadpoles that matches with their solution here. We got three lotus, right? Lotus flowers. And then we got four coils, four coiled ropes. And then we got how many? 1, 2, 3, 4, 5, 6. That matches with our downturned U's. We have six of them, and then two vertical bars. All right. So this is how we are going to go about converting from the Hindu Arabic to the Egyptian numeral system. All right. Now I have some worksheets as well uh, for this course, and I will work through more examples giving you solutions on the worksheets. All right, so you'll get more practice doing this kind of conversion. Now we will talk about the Roman numerals. The Roman number system was developed and used by the ancient Roman civilization. And as we see over here, there are 7 numerals in the Roman system. And these are all letters of the alphabet. Starts with I, then V, X, L, C, D, and M. And their number values are given here on the right hand side in Hindu Arabic numerals. So the value of the Roman numeral I is 1. Value of V is 5, X is 10, L is 50, C is 100, D is 500, and M is 1000. So as you see over here in the Roman numeral system too, there wasn't a numeral to represent the number 0 or nothing, right? So it was still not there in the Roman numeral system. Now, the values of the Roman numerals, you will notice, increases in alternate multiples of 5 and 2. What I mean by that is that the first number has a value of 1, correct? And the next value, all right, the next higher value is 1 multiplied by 5. So V is 5. The next value is 10, all right? So 5 times 2 is 10. Then we have the next one is multiplied by 5. So 10 multiplied by 5 is 50. 50 multiplied by 2 is 100. 100 multiplied by 5 is 500. And 500 multiplied by 2 is 1000. So as you see, the numbers increase in alternate multiples of 5 and 2. So if you use your inductive reasoning method, you can guess what the next value would be if there were another numeral. However, the highest value in the numeral system is m. All right, it stops there. We have just 7 numerals in the Roman system, and the other numbers are represented using a combination of these numerals. Okay. We are going to now talk about the logic behind evaluating the numerical value of the numerals or a combination of numerals in the Roman number system. We are going to compare it with the Egyptian system that we learned before, and we are also going to see if there are any advantages to the Roman system over the Egyptian system. So just to review the Egyptian system, recall that in the Egyptian system, we only use the additive principle. All right. So if there was this numeral scroll followed by an arch, to calculate, to evaluate the number this represents, what we did was we plugged in the value. We plugged in the value of this scroll, and then also we looked up the value for this arch. So I think the value of the scroll was 100 and 100, and the value of the arch was a 10. And once we plugged in those values, we added the two, and we came up with a number of 110, which is the numerical value of this particular numeral combination of the arch followed a single scroll followed by the arch. All right, so its value was 110, and it was always addition that we had to apply in order to come up with the values of different Egyptian numbers. All right, so in the Roman system, however, we do apply the additive principle, but at the same time, we also apply the subtraction principle. So to just go over an example here before we demonstrate some of the examples provided in the slide. Let me work this out while we still have space. Let's look at this Roman numeral V followed by an I. All right. To calculate the value of this numeral, what we do is we first look at the individual values of these numerals. All right. V has a value of 5 and I has a value of 1. And then we compare these two values. If the value of the numeral on the left hand side is greater than that on the right hand side, all right, if the value of the numeral on the left hand side is greater than the value on the right hand side, V is greater than I in the Roman system, then we go ahead and add the two values. All right, add. So it's going to be 5 plus 1 equal to 6, and that's the value of VI, that particular numeral. If, on the other hand, we had I followed by a V, we use the same process. We first look at the individual values of each of these numerals. So I has a value 1 and V has a value 5, and we ask, is the value on the left hand side greater than the value on the right hand side? No. If the value on the left hand side is less than the value on the right hand side, which it is in this case, then we subtract the lower value from the higher value. So 5, what we do is 5 minus 1 is equal to 4. So 4 is the value of the numeral I followed by a V. All right, whereas 6 is the value of the numeral VI, 4 being the value of IV. So that's how we figure out the values of the different Roman numbers. All right, so what I'm going to do is I'm going to erase this, and bring up some of the examples that are provided in the slide. So just give me a minute here. So the Roman numeral system uses the subtraction principle as well as the addition principle, which is a development, a step above the Egyptian system. So you could say that is one advantage. So this is the example that they have worked. All right, so we have DC equals 500 plus 100. So here we see they have used the additive principle. Now, did it need the additive principle? Let's do the comparison of the individual values of these two numerals. All right, so D has a value of 500, C has a value of 100. 500 is greater than 100. If the value on the left hand side is greater than the value on the right hand side, we add, correct? And that's why they have added. All right, so 500 plus 100 is 600. Let's see the next example. The next example is CD, and its value is shown here as 400. All right, so C has a value of 100. D has a value of 500. In this case, the value on the left hand side is less than the value on the right hand side. 100 less than 500, C less than D. Therefore, we use the subtraction principle, and that come up with a value of 400. All right, so DC has a value of 600, CD has a value of 400. All right, now another operation that the Roman system provides for is multiplication. All right, so I'm going to bring that up here now, just a second. All right, the Roman system allows and uses the multiplication principle. It uses a multiplication principle for numerals greater than 1000. Remember, the highest value of a numeral of a single numeral in the Roman system, M is the one that has the highest value, then that's 1000. All right, but to evaluate values greater than 1000, all right, we use the multiplication principle. All right, so how does the multiplication principle work? Right, in the Roman system, we only multiply by 1000. All right, because we are representing numbers greater than 1000, therefore we only multiply by 1000. So if we have, and there's a special way also to represent 1000, or special way to represent the multiplication. Let's look at this number V. All right, V is the number 5. And if we put a bar over the V, that suggests multiplication. So V bar means multiply by 1000. Multiply what by 1000? The value of V. So when we have something like V with a bar above it, then that implies 5 multiplied by 1000, which amounts to 5000. All right, let's quickly go over the examples provided here. They've used the same example, V with a bar over it. V bar is equal to 5 times 1000 equals 5000, the same example I just showed. And then let's look at the other one, CD with a bar over it. All right, so CD evaluates to 400. We already did the calculation up above here using the subtraction principle, and this bar goes over both C and D. Now it can only go over C and not over D. We will see some examples of that later on, but when it goes over both the numerals here, then we have to first calculate the value of CD, and that was 400, and then multiply it by 1000. for a value of 400,000, right? So keep in mind that, to summarize, Roman number system provides for three operations here in a limited way: the addition principle, the subtraction principle, as well as the multiplication principle. And that is an advantage, so to speak, over the Egyptian system. Now we are going to go through the exercise of converting a Roman numeral to its Hindu Arabic equivalent. All right. So what I've done here is I've listed the values of each individual Roman numeral, and the numeral that we have to convert to the Hindu Arabic numeral is this CMLXIV. Now keep in mind that in the Roman system we use the addition, the subtraction, or it can also be the multiplication principle that we may need to apply. Right? However, we can tell by just looking at the numeral there won't be any multiplication involved because there is no horizontal bar above any of these numerals or any combination of these numerals. All right, so it should be either addition principle, the additive principle, or the subtraction principles, but we'll have to figure out which ones we will have to use for what. All right, so to go about it, what I'm first going to do is I'm going to plug in the values of each individual numeral. So C has a value of 100, correct? So C has a value of 100, M has a value of 1000, L has a value of 50, X has a value of 10, I has a value of 1, and V has a value of 5. All right, so that's the first step. In the second step, I have to compare each of these numerals with the numeral adjacent to it to see whether it's less than or greater than the value or the numeral to its right. All right, so let's go one by one from the right hand side, from the left hand side to the right hand side. All right, so I'll start with 100. So I see 100 is less than 1000. So this is less than. So whenever the numeral on the left is less than the numeral on the right, that would mean we have to subtract. And we will have to complete the subtraction first always before we add. So there is some kind of order of operation there. Then we see that we compare 1000 and 50. 1000 is greater than 50, which is greater than, all right, sorry, it's greater than 50, correct? So let's do this cleanly here. So 1000 is greater than 50, so that would mean addition, all right? Then 50 is greater than 10, so that would mean addition. Then 10 is greater than 1, right? So that would mean addition. But 1 is less than 5. So here we would again have to apply the subtraction principle, but this subtraction has to be done first, all right, before we do the addition. So let's write this down now. Since there is some order of operation applied, we have to take care of the subtraction first. We will be using parentheses, we will be using brackets here. So I'm going to write this out now as now lower value subtracted from the higher value. So it's going to be 1000 minus 100. All right, so this part here, and then it's plus 50. All right, so let's go to the pen. Plus 50 plus 10, and then plus, again, this is subtraction, right? 1 less than 5 means subtract 1 from 5. So I'm going to use brackets here, 5 minus 1. All right. So I think now we are good. Let's see if we are adding everything or subtracting everything as it should be. So 1000 minus 100 is 900 plus 50 plus 10 plus 4 gives us 964, and that should be the numerical value of CMLXIV. All right, under the Roman number system. So let's look at the solution they have given us here, if they have done the same thing as we have. So solution says it's an additive system, so it's CM, right? It's CM plus L, right? So CM plus L, and that's exactly what we did. 100 less than 1000, so we did the CM first. We calculated that first, plus L plus X plus IV together, because there was subtraction involved here. The left-hand side numeral was less than the right-hand side numeral. So we had subtraction here. So they've grouped this together. Just like we used brackets here, they have used the grouping method here. Okay, so let's get the next one here. So they've done exactly the same as what we did. 1000 minus 100 to represent CM plus 50, all right, plus 50 plus 10 for the X, so plus 10, and then plus 5 minus 1 for a value of 900 plus 50 plus 10 plus 4 is 964, and that exactly matches with what we got for our answer. All right, so this is how we are going to be converting Roman numerals to the Hindu Arabic form. We will now be going through the exercise of converting from the Hindu Arabic numeral form to the Roman numeral form. So we've been given a number here, 439 in the Hindu Arabic form. So to convert that into the Roman numeral form using the Roman numerals, I have first listed the Hindu Arabic values corresponding to each of these Roman numerals, I, V, X, L, C, D, M. Now we see that 439, this value is less than 500. So when we convert it to the Roman system, we should not have to use M. Most likely the maximum or the highest value we will be using or representing is going to be a D in the Roman numeral form. But let's see how that's going to work. All right. Now the first step that we must do is break this up, all right, into 3 parts here. So I'm going to write this as, let's use a different color, 400 plus 30 plus 9. All right. Now, there's no single way to represent a 400. There's no single way to represent a 30 in the Roman numeral system, and no single way to represent the 9, right? So 400 can be represented as 500. We have to use 500 though, all right? So because it has to be represented in terms of these values only. So it's going to be 500 minus 100, correct? That's how we can represent 400. Plus, this is 3 tens, correct? This is 3 tens. And this one is, we have to represent it in form of 10 minus 1. All right, because we have a way of representing 10, we have a way of representing 1, right, with the I. So let's fill in these values here. This is D, This is C. This is going to be 3/10. There's no way to represent the 3, so we will have to put it as x 3 times, and this is going to be here. Just a second, let me erase this line. This is going to be again x, and this is going to be I. However, if it's a minus, remember the smaller value has to be on the left hand side. So we are going to write this as CD, and then 3 x's. Remember, it's not just 1x, but 3x, 3 times 10. So it's going to be x, x, x. And then the I should come before the x, so I, x. All right, so this is going to be the Roman numeral equivalent of 439. Let's look at the solution that they have provided us here. Just a second. Okay, the solution they have provided is 439. They have broken it up also as 400 plus 30 plus 9. And then they have written the 400 in terms of 500 and 100. So 400 can be written as 500 minus 100. And then there are 3 30s, right? There are 3 30s. So 10 plus 10 plus 10, and 9 also they have written in terms of 10 and 1, right? So now they have plugged in the values CD, X, 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 I, X. All right, exactly what we did here.